going to be recorded. Hello. Yes, we are recording. Great. Thank you very much. Okay, so some announcements now more seriously, okay? One of them is I postponed by 1 day the homework because I wanted to have 2 classes before it's due. I sent a message on Piazza, right? But it's going to be due on Thursday. And Lourdes, one of our TAs, also moved her office hours from Friday, when nobody would have come anyways, to Thursday. So there is also more time to actually help you, okay? I really felt bad that the previous class was not recorded, eh? There is no sound? Oh, God. Hello? No, but there is sound. I mean, I see my microphone going up and down. Okay, good. Okay, I just needed to shout. So this is the announcement number 1. The announcement number 2 is that we are working on the grading of homework 1. We have been a little bit slow. You know, I ran in a couple of personal hiccups last week, so I didn't immediately give guidance to the TAs about which things to regrade. But it will be regraded. You know, we have a list of stuff to regrade. I think we will all be very happy. I mean, maybe not very happy, but at least there will be consensus in the grades. It doesn't seem to have gone badly, by the way, from what I've seen. But you have to be a little bit more patient because we are working on regrading the issues where the consensus was not great on the Code Grader, right? And so that's what's happening. So hopefully by the end of the week, the grades for homework 1 will be out, essentially. Okay? So these are the 2 announcements. I don't have any. Am I forgetting anything, Lourdes or anybody else? If you want to say something. So, do you have any question on the class before I move on?
So for the homework, it's just on the list page. We're just using the
SQL form.grid, yes. It's the homework is a mix of teaching you how to use SQL form.grid and how to use normal forms for editing and adding, and how to do a bit of operations on the database. So it's a sort of Web2Py basics, call it. Yeah. Do you have questions on the homework actually that you would like me to things you would like me to cover?
Yeah. How do you change or edit the individual field
inside the a field inside the database? Okay, I will answer, but first let me gather questions from around. Right, I want to know essentially what are the major doubts. Any other question? Just to. What I mean by cross-site attack? No, I did it last time, and it takes me a long time to set it up. And that's the problem. I need to have these 2 sites running that contain exactly the right content. Did I show it last time? Oh, so it's not recorded. That's a bummer, right? I may record it offline, but it takes me some time to have everything set up in exactly the right way. And so I don't want to try to do it now. You had a question? Yes. No, you have more than 2 pages. Those are the official pages. And then you have some pages where you need to show the edit form and the add form.
Right. So when we log in, we're on the list page, but when we log out, should we go to homepage?
I haven't specified it, and so I will not penalize people for doing it either way, okay? Yeah. Yeah, I mean, I often don't manage to specify all the details just because, I don't know, I also feel it would be tedious for you to read a very long description. Okay, so what I wanted to do was sharing the screen and so I want to talk about database operations. First, I want to just remind you a little bit about the code. Let me see if I can make this disappear. I always forget how to do this. What is happening on the chat? Yeah, the rubric for homework 2 is available, okay? How do I minimize this thing again? Oh, goodness. Okay. Okay, great. Okay, so let me leave it there, perhaps the chat window. But why do these things want to have the precedence over the screen? I don't know, Jeff. So the thing I want to underline is this, because I see many questions on Piazza on this. So I just want to say it a moment once more. Oh, no, there are two things I want to do. So this is the view all page, and I wanted to underline this fact. In Web2Py, it is possible to create some Python variable whose content, once evaluated in the view, is HTML. I mentioned it last time, but I just want to mention it again this time. You see, this span is a Python helper that, when evaluated inside the view, will generate HTML. You may think this is a really weird object that is full of mystery, but it's not. Remember that in a view, let me take a random view, okay? Oh goodness, there is a lot of stuff here. But imagine that we don't care about the stuff that's there already. But imagine that I do something like is equal to X. What does the view framework do when it sees something like this? It says, oh, an expression, beautiful. Let me take whatever expression is after the equal sign and evaluate it, right? So if instead of having equal X, I have like span hello, okay, this will evaluate the Python function span that is defined as part of the Web2Py framework. What does the Python function span do? Well, it will generate, I just write it below, but this would be what the function span generates. It generates a span with its closet tag, and in the middle it puts hello, it puts its argument. And if you say hello and then, you know, Luca, so if you give it two arguments, it just concatenates them. No, without space in this case. If you want a space, you have to add it yourself, right? So it just takes all the arguments that are the main arguments and just spats them there, okay? And there is a Python helper, essentially, for each HTML tag. Well, I haven't checked that it's true for all of them, okay? But for everyone that I ever tried, it's true, okay? So, for example, there is one for the A tag, one for the div, one for the H1, whatever. I mean, okay? Now, suppose you want to give a class. How do you do it? So you use the properties of the tags correspond to these underscore arguments, named arguments of the function. So you say class is equal to, I don't know, btn for button, okay? I don't know why this would be a button. And this has the effect of generating a class is equal to btn here. So this means, in general, that when you need to generate HTML, you always have two choices. And it's up to you, really, and to the context, which one is the best one. One is to include the HTML directly in the template. That's slightly more efficient, right? Because it's already there, the code, and it doesn't need to be created by evaluating anything else. But if you like, the other choice that is perfectly good is to generate it in this way, in Python, okay? And this can be more flexible because, you know, you can essentially, how to put it, you know, when you set to work and you maybe relax or clean up the table and then you have your pen ready and ready to work, right? It's a bit like this. In Python, you have more access to be able to write code. I mean, you're in a code writing environment where indentation matters, the code is more readable. It's a bit better if you have to write a lot of code to write it into Python rather than try to squeeze something complicated. So if you have, you know, the HTML code generated by a lot of conditional and other clauses, it might be easier for you to generate it inside Python. Here, for example, I'm generating a span that contains an A tag, so an anchor, that contains an I tag. I tag, it used to mean italics. No, so slanted, right? The font would be slanted. But in this case, it's used as a container. It's a common usage to use it as a container for this icon, which is a FAI, I don't know how you want to pronounce it, but it's font awesome. And it's the I icon in font awesome, right? So this will generate a nice span for contain, of this class. Then there is a space, then there is a string view. This is inside the anchor, right? The href of the anchor is this URL. The class is btn, and the class of the span is haha, which is completely useless. But I just wanted to give you an example when we were, in class last time. So I just want to mention, and the other thing that you want, I find it psychologically important for me, and maybe it is for you as well, when you try to write something complicated, to take the time to actually write it nicely. So if you find that this lambda expression, lambda row colon, is slightly mind-boggling and you don't want to write something very complicated there, and sometimes I'm of that opinion too, you can do like this. You can say lambda row, and then you can just call a named function that has as argument the row. And then you can define your named function in all its glory in some other place. You see? So you can essentially divide your code into smaller pieces and focus on each piece at a time without trying to squish everything in some complicated way in place necessarily. Yes? I beg your pardon? Oh, yes. You're saying I'm just stupid because I could have, you don't say it because you're polite. But you could say, you say that I could just write here, produce funny button right here. Yeah, I could do this. The lambda function is just a way to create an unnamed function. And I think it's just that, I have some automatic completion in my fingers. So whenever I say body is equal to lambda row colon, and I always write it even if it's useless. But in this case, it would be, you could just take the shortcut. All you need to do is provide a function. Okay, so that would be good. Well, that would be, thank you for the question. That's a very good thing. Okay. So one of the advices I give you is not to try to squish things, but to try to sort of, write them in the way that is the clearest one. And the other advice I give you, because I'm horrified when I look at homework sometimes, is that, sometimes I read these functions that are called, star the item. And in truth, what you're doing is, thumbing it down. But it's because this coding class called the function star it. And so everybody keeps the name star it, even though the semantics is completely different. Please don't do it. I completely cringe when I see that. It tells me that you are so afraid of changing things that you don't even change the name of my functions to represent what they do. And so I understand that you cringe, but be bolder. Okay. So name things for their real purpose. Okay. So this is one of the things I wanted to tell you. The other thing that I wanted to do, because I realize it's complicated, I wanted to go a little bit more on form processing. Where is that we have some forms processing? I think it's above. Yeah, here we have the form for editing a record, which also I think was part of one of the questions, right? So are there any questions at this point on what I've done? Is it clear that you can produce HTML either from Python or from inside a template? Are these things clear so far? Okay. Yeah, sorry, I have audio on and messaging on. Maybe I should shut off this audio. So I want to again go over how an edit form is done and how validation works. Okay, so this is an edit controller, and it first does a bunch of validation, which unfortunately is often needed because you need to, you cannot trust the request to the form to know that the person may be authorized to do it. So you have this sort of boring authorization code. But then you are creating the form. And you can create it in various ways. So this is by creating it corresponding to a database table. And we could do it in a similar way. Actually, it might be useful to do it afterwards, in which I create it explicitly so that you can see again as an overview the two ways of creating a form. Sorry if I insist, but it's very handy and it's kind of fundamental to make how many things work. So when you create the form, this form SQL form function, internally, you can go read it actually. And internally, it has an if-then else that says something like this. If I didn't receive any form, it means that, that the user landed here for the first time and they must generate a fresh form. So a fresh form is generated into form. The process method doesn't do anything because, you know, if the form is fresh, there is nothing to process yet. And the function just returns to you the form. The user will be, you know, staring at a form. They will fill it in, and then they will click on submit. And so the same function, because in Web2Py the tradition is to submit forms to the same method where they were created. You know, you could change this if you wanted, but I don't particularly advise it. You know, it's easy, much easier to keep it in place. So Web2Py will receive the form, and so there was a very nice question on Piazza at the beginning. The thing, let me write it. In fact, here there is form. Request dot vars dot post title. Okay, so the information that comes back to you comes back into variables. Okay, this is each variable corresponds to a name in an input field. You know, the names in the input field specify how the information in the input fields are sent to the server. Okay, and so you receive them into things that are request.vars.postTitle. Request is this object that summarizes many of the things that you receive when you receive a request. Okay. Now, once you do form a process, you can do here instead logger. How did I define it? Logger or logging? I'm afraid I don't remember. I work on two projects in which I call it two different ways. Logger is fine, eh? Logging. Yeah, I'm sorry. I'm using two different conventions in two works I'm doing at the same time, and so I'm a bit confused. But for example, you can say logging info. The title is. Let me give you some other hints. You must know about formatting characters in Python, right? So you have formatting for integers, float, string. Okay, forget about it if you do logging. You just always use the %var. %var uses the representation of the field. And it's very useful in debugging because if by any chance you believe that something is an integer, but actually the something comes in as a string, you know, this %var works nevertheless, okay? And so now, because we have processed the form, the variables are available also as form.vars.postTitle. And, you know, let me add another comment. I'm sorry, I'm junking the code with various things, but I just want to be able to annotate in place. So if we had an integer, we would have that request .vars. I don't know, count would be a string. Okay. The reason is this, you know, when things are transmitted by web forms, the web forms do not know the Python typing conventions. So things are passed as the user types them. And so if a user has a, you know, an input field and types 12, the 12 is sent as a string 12 across the form, okay? So when you get it, it's gonna be a string. And so the problem is that, but here, okay, you could say that you could do the following: logging info, count, okay, %d, because here actually form vars.count, here it's processed and validated to an integer, okay? So when you do the form processing, you essentially validate all the possible values, okay? What does it mean to validate? Well, for the gory details, I think I would like to send you a little bit to read the chapter on forms and validators, which is one of the chapters of the Web5 book. But in a short way, here, you know, if I had you know, I don't know, field post count integer, okay. Oh, actually, I have a view count already. I'm sorry. I could have done all these examples, okay? But you see that I can have a requires. These require fields establish constraints, and the formal validation, when you do process, will automatically check that those constraints are satisfied. There is a bunch of these validators available that enables you to specify all kinds of properties of input that are automatically validated by WebPy, and that the proper error message is inserted if the thing is not valid. Okay, so that's extremely useful to do. Let me just clean up the code a little bit, actually. This is like a view count, right? So in fact, we can, you know, let me actually do it rather than just claim it, okay? So what do you do if you have a bit of doubt? You do, sorry, 1 second that I need to think. Logging info, okay? Type %, okay? Type is a Python operator, okay, and it will return the type of the thing, okay? So this should work, actually. So if request vars, I think this just works. Let me try. Maybe I'm wrong, okay? Let me see if I can edit this code and get the behavior I want, okay? Maybe it breaks because I played around with the code a bit. Let me also delete this extra code I wrote. Sorry, I'm confused a moment. Here I need to go. Okay, so I should click on edit. This gives me an empty form. Oh no, this gives me... Okay, so this is the form, view count. I can say, I don't know, that is 44. Okay, now I submit. Okay, now this goes to, I don't know why this goes to this page, because I still have the old redirect, I think, at the end of it. Okay, never mind that. But let me look rather at what has been logged. Okay, and so, oh, I think it's just not directing to the right, yeah, to the right edit function. Let me fix it a moment. So here I'm playing with the edit. Wait. No, this was edit. So why was it? Why was it not giving me what? Yeah. Great. So now it's recorded. What did? Yeah, dangers of logging everything there, right? But it's not my secure password. Don't worry. But why was this not logged? Okay, so I don't know. Maybe because I need to say logger. Let me try a moment. I mean, I define these things in db.py. So if I just try to maybe read my code instead of guessing, maybe that would be better, right? It's called logger. You can see it. I just used the wrong name in my code. And it's because, as I mentioned, unfortunately, I have two projects where I have opposite conventions and that I work a lot on. And so let me rerun this code with the right name in 1 second. I don't need to rerun the code, but I just need to sort of, so now I click on edit somewhere and I say 22, submit. Okay, and now we should be able to see the logs. Yeah, you see at the beginning the type is string, and then instead it's 22, it's converted to a number. So essentially the form processing automatically takes care of all the validation that you specify in the requires field in the declaration of the tables. And you should look at it if you do a project. There is, Web2Py, forms, validators. There is a very large number of validators that are quite useful. So yeah, at some point you should probably look at the book and read. For example, it's not empty, it's not in database, it's upper, it's an email, it's a match, it's long like this, it's not like that, it's a URL, it's a slug, not a banana slug. It's a date time, is in a range, is not in a range, is whatever, right? So if you find it there, it's great. If you don't find it there, if you look at the book, there are recipes for defining your own validators, okay? One of the limits of validators is that validators validate one field at a time, and that sometimes you want to do validation that is more complex. It's based on the whole form. For example, you may want to write a validator that says, I don't know, that I don't have any great example in mind, but imagine that you are writing, imagine that you are buying stuff, okay? And the thing has a unit price and there is an amount of you want to buy, right? And maybe you want to flag if the product of the unit price times the quantity is over $1,000, maybe you want to give a message, please, you need to call in this order. You cannot do it via the web interface because, maybe high value orders have to take another process. I don't know, whatever, right? So imagine that you have some validation that you want to do on the whole form. The way to do that is what I did here by defining a non-validation function that you call explicitly. The validation function here, I called it mychecks. I saw that there were some questions on Piazza about it. And the mychecks function, unfortunately, I think it ended up where? Sorry, I'm swimming a bit. Oh, it's right here, actually. So in the mychecks function, you have already all the validated variables. So the integers are now integers, the floating points are floating points. The basic sanitization by the form has already been done. And you have things available in the forms.vars, whatever it is. So the basic cleanup is done. You don't have to concern yourself with that. But you can write any other condition you want. So here is how you access the view count, form.vars.view count. And if you decide that you want to report an error to the user, you simply decide form.errors.viewCount. You have to decide to which field of the form to associate the error. When the error is printed out for the user, it will appear below a specific field. So you have to decide which one, and then you can write your own error message. So this is a simple way to give you complete freedom to do whatever you want. And now this validator is simple, but one of the reasons I use validator sometimes is this. For example, you want to buy, I don't know, sorry, my examples are a bit silly today, but you want to buy candies, okay? And I want to check that after you buy candies, I have at least 10 left in store, right? So these I need to read the database in order to validate your form. Well, I can do it because this is a function in which I have access to everything, right? I know which color candies you want to buy, which flavor candies you want to buy, and if you are buying strawberry candies, I can then do a search and ask for the quantity in stock of the strawberry candies, subtract how many you want to order, and check that what remains is greater than 10, and otherwise tell you, sorry, I won't sell you that many because I will be too low on stock for when the kids come out of school, something like that. I mean, it's just an example. But it indicates how you have, complete freedom to do whatever checks, but still exploit the Web2Py way of presenting the error to the user, which is, I think, pretty useful, because if you have to code it yourself, it's a little bit of a pain. Okay, so with these, essentially, unless there are questions, I would like to conclude a little bit the part of Web2Py that I call the basics. Which is how do you define database tables. I will talk more about database in what follows, but at least you know how you define a table, how you process a form, and how you validate a form, and how you produce with SQL grid something that can show many records at once. This is sort of the plain vanilla basic that is often needed. And one of the reasons that I think Web2Py is kind of nice is that it sort of gives you these as already easy to use. Okay, so are there questions on this part? Yeah. Yes. Yes.
Do you call that function, or does it return you the value?
Yeah, so request is an object that has many fields. You can go look at it in I believe it's the overview chapter or something like that. And sometimes you need to fish into it. For example, a request contains information about which IP address the request comes from, which kind of browser, whatever else, right? There is also a timestamp, whatever. But among the things is that there is a request. In fact, let me maybe cover it a little bit better. But okay, let me give you the reply, but then cover it a bit better, because I think you're right. There is more to be said. The request.vars is a container that contains all the variables that come in. Okay? And so if you say a request.vars. I don't know, wolf, if there is no wolf variable, this will be evaluated to none. Okay, it's a container that is sort of permissive. You know that dictionaries get upset if you seek for a key that's not there. And so dictionaries get all upset and say key error, right? And instead, there is a container object that Massimo defined, and I could show you how to define them in Python. It's a very useful hack. It's a super useful hack, and maybe I should do it the next time. I just don't want to waste time searching for the code, but it's really beautiful, I have to tell you. These are sort of permissive. So if the thing is missing, instead of getting annoyed and blowing up with an exception, they simply return none. Okay? Now, what I haven't explained to you is the following, and maybe let me get a piece of blank code where to write it, because sorry, let me just write. Okay, examples.py. So for a post form, so I told you basically that post forms should be post forms if you want to change the database, right? And so in fact, this is my advice. But the post will go to something like start, default, edit, just as an example, okay? And then there is the post variables encoded in a form in HTTP. This means that when you do a post, actually, if you looked at what happens on the wire, there is a little bit of back and forth. What the browser is telling the server is something like this: hey, I want to do a post to start default edit. And the server replies, yes, go ahead. and then the browser replies, here it is, and passes the content of the form. Okay, it's not done in a single transaction. It's not done in a single TCP/IP packet in the network. Okay, there is, I want to do a post. Yes, here is the post content. Okay, this enables you to send very large content. I think I mentioned it already in maybe last time, but this enables you to send large content. Okay, and then you have on the receiving end you have request. Request.vars.x, that is my variable x, but you also have, if you like, request.postvars.x, okay, which means not only, there is the variables are post variables, so the post variables are these ones, okay, the variables that are transmitted as part of a post form. Now, if you did, if you do a get post, a get form, and I write don't, okay, but you can. I mean, if you know what you're doing, you can do it for some applications. Then the URL would be something like start default edit x is equal to 6. Okay, just an example. So essentially, in a get, the values of the variables are transmitted on the URL itself. And there is a limit so the URL limit, if I'm not wrong, is 2048. Okay, so you cannot have an arbitrarily long URLs. Okay, so you cannot transmit very large stuff. You cannot like write your essay and then transmit it in a get form submission. Okay, and then you would have like a request vars x again, but you also would have a request get vars x. Okay. Now, why there is distinction between get vars and post vars? Because if you are perverted enough, you can actually use both. Because you could cause, again, it's a matter of perversion, I think, right? But you could cause a post to be submitted to a URL that contains a question mark via post. It's not forbidden, right? It's only that you have to cook it up yourself. But if you cook it up yourself that way, then the variables in the URL are part of the get variables, and the variables in the form are part of the post variables. And if you are really suicidal, you could almost have the same variable appearing in the URL and in the form. You know, this is a recipe for shooting yourself in the foot, because it's great cause for confusion. Okay, but you could do silly things like that if you wanted. So, but don't do them. But essentially, you can always check whether a variable was transmitted to you in a form or along the URL by checking whether it's part of get vars or post vars. Okay? So what is the advantage of gets? The advantage of gets is that due to the limitation in length as well, they often travel in a single packet. Okay? A get request to a certain port often can put the whole content inside because it's just a URL. It says get this URL, right? That's a request right there. And so it's a single packet, and there is no round trip. It's not so much how many packets it is; it's how many round trips it is. Because if you are on a cell phone and you have a 60 millisecond delay from your phone to the server due to whatever happens on the wireless network and whatever, right? If you are in that situation, if you have only one round trip, is 120 milliseconds of latency before you get the answer. And if you have two round trips in a post form, you have to double that, 240. And so, so if you care about latency, you may want to use get requests for some purposes if you know that they are short. Okay? Does this answer more or less... I mean, it says a bit more, but so are you happy with the answer?
So I know, like for since we're not doing JavaScript, we do the small changes on our web page.
Yeah, we need to reload the whole web page for the moment. Yeah.
So we just modify a request of variable.
Yeah, and so to do that, I wrote a silly method, right? That I called how did I call it? Write back. Okay, here I'm sending you to the write back controller. The write back controller does some stuff and then redirects you back to the view. And so this is a silly way of doing it, but okay, but I just wanted to give it to you also for comparison with what will come later in class. It's a silly way because, you know, the SQL form grid also takes care of pagination. But if you are on page 15 of a long list of products and you're scrolling and you click on this button, this will just redirect you back to the beginning of the grid. There is a way to avoid it, you know, because I could include in the URL to which I redirect a page value. So how would I do it actually if I wanted to redirect you in the smart way? So okay, let me try to do it. Okay, so imagine you have okay, I think it's good enough as an example. Let me try a moment. Pagination is equal to 2. So now I want to have only 2 elements per page. Sorry, but I think that this may be a useful example. 1 second, okay? So so here I add another post. Yeah, is this sensational? Do I have a muscle twitching? And then you realize it's a phone, right? Third post. Hello there. Okay, so in this way, if I add it, if I go to the, I'm sorry, I need to lower this. Not to index, but I go to, how I call it, view all. Right, I broke something. Not, oh, it's not pagination. I think it's paginate. 1 second, okay? Yes. You see, it tells me whether I want to see page 1 or 2. And if I am on a particular page, I mean, this is a useful example because it tells you a bit how to play with variables on a URL. Look at it. There is this page, question mark page is equals to 1. This means the following, okay? That we have a variable available which is called page. Ta-da! So in this write back method, suppose I pass it which page I'm on. So when the write back method sends me back, it will send me back on the same page of product list. Okay? At least you can implement these things without using Ajax in a way that is not too overly horrible. You still have to reload the page, but at least it leaves you in the same page you are staring at. Okay? So imagine we have to do this. Yeah. The signature is produced automatically by SQLform.grid. We don't need to produce it, and it's produced as a security measure in case we enable the SQLform.grid ability to do edit or add of records. Okay, and in this case we don't need to pay attention to it so much. But yes, you are right. We have also the underscore signature variable, as you got. Okay, good. So let me do this then. You know, here I may have a variable that is called page, and I want to pass it to this write back method. Okay. So you see that I'm passing out is equal to row ID, and now I just want to give it another argument. Okay, that is called vars. No, I can specify what are the variables. Vars is equal to dictionary. Page is equal to request vars page. Okay, so this will tell the write back method which page I'm on. Maybe it will say none, you know, because maybe the page variable is missing, but it will contain something. Okay. So, but suppose I want to include it only if page is not none. How do I do it? Well, I say request vars page if request, no, I can say, okay, okay, let me do this. No, I don't want to include a none. Okay, so I can always use an inline conditional in Python. Vars is equal to an empty dictionary if request vars page is none, else is equal to that dictionary. Okay, please, you know, don't kill me, but I know it's not super beautiful code. Okay, but I just want to be quick. Okay, so I included the page variable if there is some page, if I'm staring at some page. Now let me fix the write back function. What I have to fix is here, right? And so I have to say the following: if request vars page is not none. So if you did specify a page, then I want to send you back to the same page. Else, I just send you back to the generic place. Okay, and the special, and here I can simply say this is a URL where vars is equal to a dictionary, page is equal to the sorry, a page is equal to request vars page. Okay, so I preserve it. I'm essentially sort of, you know, keeping it on and forwarding it back. Okay, let's see whether this stuff works. I have no idea, but you know, if I'm lucky, it does. So so I need to reload this page because you know, I want. So let's go to page 2, so the behavior is more obvious. So what did I? Oh, the write back function is this one. Okay, this is silly. You know, I hate Safari for not telling me the URL on which I'm about to click. So let me inspect the element a second, just to show you what the URL is before I click on it. Okay. So you see now it says write back 5 page is equal to 2. Aha! So I'm passing the right page when I click on write back. Where did the write back disappear? Oh, goodness. Anyway, so now when I click on write back, if I'm lucky, I should be back on page 2, not on page 1. Ta-ta-da. Yes. I mean, it's you know, the most unimpressive demo I've ever given. But you see the view count is increasing if you squint your eyes and notice, right? And so this means that the write back function is being called and is redirecting back with the right value in the page. Okay, so essentially this tells you better how you can manufacture URLs to preserve context information. By the way, this is the same as when you try to access something when you're not logged in. If you try to access a page called, for example, edit, and you're not logged in, you will see that you are redirected to the login page, and there is a variable next is equal to /start/default/edit. So it's telling the login system where to forward you once you have completed the login procedure, right? So it's a commonly used mechanism, this one of you know, remembering context information in the next variable. In general, you have a choice of 2 places where to put this context information. One is the session, and the other one are these URL variables. So you have to wonder, what is the best choice? And the answer is kind of simple. The user session, you know how to access the user session. You know, I could access it in this way. I could access by, for example, saying, you know, session.page is equal to request vars page. No, I mean, that's how you would store something in the session. But what is the difference? Essentially, the session is global for the user. The user may be visiting your site via multiple browsers, maybe via both a phone and a laptop. And even in the laptop, they have maybe multiple tabs open on your site, right? Because, I mean, you do this all the time when you're shopping online, right? You have a list of products, and then you open another tab on the same shopping site because you want to do another search and compare the results with the first, and so you have 2 lists of products. So the stuff that you put in the session is global to the user. It's not particular to the context of each page the user is looking at. For example, a shopping cart is something you may want to put in the session because, you know, if I add it from one tab or from the other tab, my shopping cart is going to be the same. And when I check out, I want to check out everything I've put in the cart. It's not per page, typically. I mean, I'm sure you have noticed on Amazon, right? And on many other sites. Instead, this information, like I'm writing now, about the page you want to go back, if you click right back, this is kind of local information because you know you want if you are on page 2, you are on page 2 on this particular tab. You are not page 2 on all your tabs, obviously. And so this kind of information is better communicated via URL variables rather than information in the section. Okay. So I know that there are multiple places where you can store information, and it requires a bit of judgment where to put it. Okay. Okay, you know, a really long detour, but I think that these are useful things to know. Any other question at this point? Okay. So I want to do a super short. There is a fly that wants to eat me. So I just want to take attendance while we relax a moment, and then I want to, where is it, the attendance thingy? Hey, this one. And then I would like to move on to databases in a bit more of a formal way. So a moment of preparation. There is only one question, essentially. I'm asking what you would like to see in review sessions. Hey, why is this making lines? What is happening? Is there somebody drawing on the Zoom call? Does it really work? Can people draw both ways and I see the drawing of other people? Sorry. Yeah, but this is weird. No, it may be so. You know, I think if somebody joins with an iPad, maybe they can draw, but I didn't know that I would be able to draw on my screen. Maybe so.
Uh-oh, there's green.
Yeah. Yeah, there is somebody drawing.
Oh no, they're gonna drop these.
Yes.
Don't do it.
Don't draw more, otherwise I need to discover how to stop the drawings. I mean, I could...
It deleted it.
Oh. Yeah, maybe they're all chatting about it. I mean, if it was me, you know, I would... oh, annotate, yeah. La la la. Oh, cute. That's me. Now, how do I... okay, clear. Clear all drawings. Okay, cute. Thank you. It was a discovery. Okay. Yeah, no, I want my normal cursor. Help. Yeah, the click annotate, yeah. Okay, so I wanted to tell you a little bit about databases because so far, you know, we learned how to do a table, but I wanted to give you a better version of it. So let me try to present. Where is the present button? You would imagine that it's more prominent. Do. Okay. Okay, so I mean, one of the first questions is why do you need a database? You know, why do you need to bother with a database? You probably have written a lot of web code that does actually not use a database. I mean, a lot of general code that doesn't use a database. And so you're wondering, you know, now how comes that I need to play with a database when I want to develop for the web? And a database essentially has various separate functions that are interesting in themselves. One is persistency, right? You want to be able to create data that persists through, you would call them program runs, but these being the web, modern program runs are visits by users. No? So you need some place where to store information. Now, this is okay, but you know, so far we have probably stored a lot of information without using a database. What do you do with information normally? Well, you might encode it in some format and dump it in a file on disk, right? That's what you do very often in programming classes, right? You have a lot of information, you zoom and you put it on a file, and then you open the file back again and you read it, right? That's what you do. So why do you need a database particularly? Well, because of the other reasons. One is concurrent access to data. So essentially, when you build a website, you normally have more than one computer that serves the web pages. So to be very concrete, the Web2Py, in your case, would be running on more than one virtual machine or computer, because you need to be able to respond to a certain volume of requests. If every request takes you, say, 200 milliseconds to answer, and if you have only one server, you can only satisfy 5 requests per second. If a visitor to your site is likely to click on a button and do a request every, say, 10 seconds, with the 5 requests a second, you can accommodate only 50 visitors, right? So if you want to accommodate 1,000 simultaneous visitors, you need 20, they're called front-end machines that run Web2Py, and that serve the web pages, right? And the problem is this, that the information cannot be written then in a file in one of these 20 machines, because these so-called front-end machines, typically, if you, but almost always, need to be able to come up and go down dynamically according to the load, right? You typically don't want to say, hey, you know, at Christmas I'm going to get a lot of shoppers, so better buy 1,000 machines and leave them all up all the time. You know, when you normally the number that you need is much lower, right? You want to be able to bring them up and shut them down. And so if I receive your request on one of the machines, machine number 12, and then I shut it down, where is your information? Well, it's gone, right? Because now the machine is down. So you cannot store persistent information in the front-end servers. And what you do in a web serving environment is that you divided the tasks. The front-end servers, what I call the web host here in this slide, essentially are in charge of the computation. They serve the web pages and they can be created or shut down on demand. Now, we will discuss later in the class how to do this in a smart way, right? So what you want to do is you want to be able to create them quickly and make them come up quickly and shut them down quickly so that you are adaptive to the demand and you don't pay too much money on the cloud. We will see how to do this. But in general, these web hosts are in charge of the computation. And the storage instead is in charge of a database, okay, that is centralized. This doesn't go up and down like a yo-yo. This is always up, and these web hosts can connect via network call to the database that is running on a separate machine. Okay, so in fact, the separate machine is so the database server typically is expensive, much more expensive compared to the web hosts. Each web host, at least, each web host can be a small machine because it's your decision, actually, the power of the web host. You know, if it's less powerful, it just means you have to spin up more of them. And so what you do when you develop a website is really you do some back of the envelope calculations. You know, if they're this powerful, how much do they cost? How many do I need in order to serve my traffic? And you know, and this is the type of considerations. But they never really become a bottleneck. If you want more, you can always spin up more of them. I mean, Amazon Cloud, Google Cloud, the Azure Cloud from Microsoft, all these clouds enable you to spin up more of these front-end servers if you need them, right? That's never an issue. But the issue is that the database, rather, is the central place that will receive all the requests to modify the data and to read the data. So the database server, per se, can be a bottleneck. And you know, companies like Oracle, for example, make their business by configuring the software and selling you the very powerful hardware that is able to handle very high volumes of requests in a single database that is centralized and that offers a consistent view of the data to whoever is talking to it in order to do transactions, okay? So these objects can be more expensive. And later in the class, we will also discuss, you know, how people have tried to make the database server be less expensive by also spreading it over multiple servers. But if you are using SQL as we are doing now, this needs to be generally a single server. You can define read replicas. You can define replicas that you can send the queries to in order to read the data. But ultimately, all these replicas need to be consistent. And so whenever you write the data has to be propagated to all the copies before it's considered committed into the system, okay? So usually this is expensive. I mean, it's not incredibly expensive, but this, you know, this takes more of your blood when it scales up, blood intending money, no? So you have to pay more because you have to pay for machines that are bigger. You know, at the big end, this becomes machines with, I don't know, 64 or 128 gigs of RAM, 64 cores, and I don't know how much hardware, and the machine itself may cost $50,000, and I don't know what else, right? These can be big, expensive machines, actually, okay? But reason number two of why you need a database is this. You want a consistent place where to store the data to which many clients can connect. Reason number three is data replication. So even if you have a database, in fact, in all kinds of databases, as SQL or other kinds, you can always define replication, which means you can always configure your database to act in such a way that everything that you write to your main database is also sent to various numbers of backup copies that, if you are smart, you distribute geographically across the nation or across the world, so that, you know, if a data center catches fire, you don't lose all your data. And data centers do catch fire, right? There is a lot of electricity in them. It has happened multiple times. I think once there was a small plane that crashed into one. I mean, stuff happens in data centers, right? And so the other solution is data replication. You could, of course, do it with a file system as well. But file systems were not created to keep data replicated. You know, if you have a file system of a Linux host here, you can replicate it there. You know, there are tools like rsync and other tools, but these tools do not really replicate it in real time. Instead, databases really have built inside these replication protocols, so that they are good at every time you do a write on a database to forward the writes to all the other. They're called slave databases. That do all the writes, but you know, don't respond to queries and are used as offline replicas. And then there are also mechanisms, because the replicas are fundamentally identical to the main one, so that if the main one does catch fire, you can move you know, the database to the requests to another database. You can say, now connect to another of my databases. While you know, buy one more machine, you can redirect users to another one, right? So data replication is another important reason. So essentially, databases give us these three things: where to write the data, how to manage it in such a way that, and we will see more on these, so that it's kept consistent, and data replication. So types of databases. There are essentially two big types that are in use in industry, and I think I'll come over them later, but one is SQL databases that were invented, you know that I don't know it, I think well over 20 years ago, maybe between 20 and 30 years ago. Before SQL databases, there was a plethora of databases that were all they all had their proprietary languages. IBM had its own hierarchical database, other companies had their own, and there was no standard way in which to write a database query. And so SQL, SQL query language, was a unifying language that was meant to be simple enough for company managers and executives that were not necessarily computer scientists to be able to write queries and see what was happening in their company, right? And so, in fact, SQL is fairly easy to use, in my opinion. So the idea of an SQL database, I mean, this is a super rough idea, okay? But information is organized in a number of tables, and the tables can be related to each other. And I will show you later in this class and also next time how these tables are related and are defined, okay? Let me just do one thing. I just want to, come on, everything is slow. Annoying. I don't want to load the responses. Why does Google always want to do something I don't want to do? Okay. 1 second. Okay, it goes into the category of problems I will solve later. Let me continue the presentation. Can somebody click on delete all? No, wait. Clear. Sorry?
You go back to indicate. And then go to clear.
Yeah, I did that.
Right, but then there's an option to clear viewers drawings so that they can be
yeah, but that's what I did. I did clear all drawings. But you know, they can still draw. That's a fact. They only clear the past, not the future. Okay, so what is the point about MySQL databases? Okay, so they are SQL databases. They are a mature technology. They work very well. They give you a very good notion of consistency. We will see later what this means, but this means essentially that the various hosts that connect to the database are likely to see a consistent view of the data in the database, okay? Yeah, I don't see that there are 10 seats available on a plane while he sees that there are 17, right? We tend to see a consistent view. Or if I try to buy a seat and he tries to buy the same seat, only one of us will succeed. You know, there are all these consistency things that make so that it's kind of easier to write a reasonable application. If I were to write an application for banking, I would like to run it on top of a SQL database, because in that way, you know, when I move money from my account to say my wife's account, you know, this is done as a transaction, and as many dollars are taken from one account as they are put on the other, you know, and they don't disappear midway because one subtraction worked but the other addition didn't, you know, these kind of things. So SQL databases are very good for consistency, for keeping the data inconsistent, and I will say later what it means. And frankly, they're very cheap. The technology is very mature, and you can easily buy a database that processes 500 transactions per second, 500 you know, queries per second at a cost of well below $100 a month on various clouds, right? So the pricing is actually pretty good. And if you want a lot of very fast transactions, it works well. The limit is that SQL databases, because they offer you a consistent view of data, need to have some logic that keeps the data consistent. And that means in practice that they need to run on one main host. You can have read replicas in which you replicate some of the data that is read. The Wikipedia, for example, is based on a MySQL database that has many read replicas to lessen the load. But there is one master copy that is the right copy, which is, you know, when you make a page edit, that's where it's recorded. And that right copy is a single machine. It's probably a very expensive machine that you know that they are running. If it fails, they can switch to another one. But at any given time, there is one to ensure consistency. So, for example, if you are if you are Twitter, you wouldn't be able to use a single database in order to store all your tweets. It would be too many read and writes per second, and it would be too much information in total for you to be able to squeeze it into a single database. That's an example of thing you cannot do, okay? On Twitter, you can very easily encode the follower relationship in a database, and that will be very useful. I follow him, he follows him, he follows her, and whatever. No? So if you want to analyze this follower relation, it's very nice and well done, but for tweets, you clearly would have to use a different kind of storage, okay? So non-relational databases or non-SQL databases were born out of the idea that just as we made the web scale by having multiple front-end servers, we need to make database scale by breaking up their monolithicity. I mean, we cannot use monolithic monolithic databases anymore. We have to split them into multiple machines. And so a typical paradigm is this. Instead of storing data in tables that are organized in complex ways, you basically store data in things that look like dictionaries, key and values. The key can be, I don't know, my social security number, for instance, and the value can be data about me, okay? And then what do? Well, then you get a bunch of computers, maybe you get a dozen of them, and you say, fine, now my key space is divided among these dozen of computers, right? So you get somebody's social security number, you compute a hash of it, you take the remainder modulo 12, and that tells you which one of the 12 machines has that person's information. Okay, so you divide essentially the task of storing information across multiple computers. So if you read and write information about me, your view is still consistent because all the information about me is corresponds to a single key and is in a single place. But if you want to do a query more in general, you don't have consistency across multiple entities because the multiple entities are stored in multiple places. And so, you know, the notions of consistency are harder. And the kind of queries you can answer are also sometimes more constrained because some operations like sort everybody according to last name become complicated, where when the information is not in a single place but is spread randomly according many machines. You know, every machine can sort their own listing, but then, you know, you have to figure out how to merge the listings of each machine into a single one. So there are some constraints there in various ways. And so, you know, this is just a purely very high-level introduction. I want to introduce relational databases now, and later in the class I will talk about NoSQL databases, basically. There is, you know, many of these MongoDB, Google Bigtable, what is the other main? Sorry, not Anaconda, the Cassandra, and there are many others. Okay. Now, sorry, something funny is happening. Oh yeah, goodness. Ugh. I just want to. Oh. Not on annotate anymore. Okay. So in a relational database like the ones we are using Web2Py, the main notion is that of a table. Okay. The table has various columns, but there is always, I mean, you could eliminate. It's not given. But in practice, in Web2Py, you will always have a column that is an ID column that is of type auto-increment. So every time you insert data, you don't have to worry about giving it a unique ID. The database will provide to that. Okay, and we'll keep count. So every table must have a primary key, essentially a combination of columns that uniquely identifies a record. In our case, the primary key will be almost always the ID of a row, right? If I give you the ID of a row, the database will know that that is the way to identify the row. Okay. So these are typical queries that you can write in SQL, and these queries are useful if you access SQL from the command line. and they're useful if you do data science in general. You can write things like select, then you say which fields from, you give the name of the table, then you say where, and you give a condition. That can be a condition or a condition and another condition, etc. Okay, so this is the syntax, and you can look it up. You know, I do it all the time because I forget sometimes the syntax for complicated queries. But this gives you the sort of the real bread and butter basics of a query syntax. You say select which columns. If you put an asterisk, it will select all of them. From, and you say which table. If you don't say anything, you select all the values. Okay, and you can say maybe limit 10 in order to get only 10 of them. These things are useful. Otherwise, you say where, and you give the clause. And you can also give things like order by GPA descending or by this ascending, right? So you can do these kind of things. Okay. Now this same query, I'm sorry, this thing popped up. Oh, how do I? Okay. This same query, you can write it in Web2Py in this way. You have the DB operator, and so inside of the DB operator, you place the query. Okay, so you say DB students GPA, you know, DB, you don't have a direct way of accessing the fields of a table because, you know, you cannot say students and say, you know, students what, you know, I mean, what is students? Students is a table name, okay, but who knows about the table names? Well, the database does. So you say DB.students is the students table. .gpa, that's the GPA column, right? That's how you do it. And then you can say select, and you can specify, I'm sorry, this thing pops up all the time, but you can select which fields you want. Obnoxious, right? Okay, so one thing that you can also do is that you can create indices on the tables. The indices typically need to correspond to the queries. If you look up often people by name in a table, it's good to, by email, for example, if in the students table you look at people by email all the time, you may want to create an index over the emails, and you create it this way: create index email index on students email. Okay, and you can do it also on 2 columns. For example, suppose that my typical query is I want in alphabetical order all the people that are I don't know. All the people that have a GPA above 3, right? Then I would create an index first on GPA and then on the name. First, because the query is going to be executed by first looking up, you know, the threshold by GPA and then sorting. And so it would help to have an index on GPA and the name in order to be able to fish out these people one by one. You know, if you don't create an index, the only way would be for the database engine to read all the data, sort it in memory, and then give it back to you, which is quite heavy. So the indices, Web2Py does not help you to create them. And my general suggestion is that you wait a moment to create indices. You don't do it when you develop the first prototypes of the app, because you're often going to change the way your database tables work, and you don't want to mess around with indices. But when your app is starting to work and you're thinking about deploying it, one of the very first things you do after deploying it is creating the indices. And there is also a useful, pragmatic way of doing it. You deploy your app without any indices, and then you wait and see which queries run very slowly. There is a way to ask a database for which queries run very slowly, and then you create the corresponding indices. Or you can even look at it, you know, by looking at the logs. We will see these things later. You can look at the logs and you can see which queries take very long time, which accesses, you know, to your website take very long. So this is the SQL format for an insert. You say insert into, and you give the table name, and then you say which columns are affected by the insert, of which columns you specify the values, and then you specify the various values. Okay. And there is a way to specify what to do in case the data already exists. But this is how you do it in Web2Py. Okay, so in Web2Py, you rather than using that syntax, you do it using this syntax. And the other thing you can do in Web2Py, sometimes you say, hey, I want to update this, I want to update this field, but if it doesn't exist, I want to add it. So there is a way to say update or insert. This contains a query. If the query returns a record, then you are updating that record. If the query doesn't return a record, then you basically do an insert. This is very useful in many cases, right? Yes.
Do you often do all of this in a specific controller for a database? Or
yes.
Do you create your own controller for the database?
These is pieces of code that will be found in controllers. And in fact, now that I give you this presentation, let me jump ahead a moment and go out of order, because I want to tell you one thing, because you may be wondering at this point. Sorry, sometimes I realize only when I explain things that it doesn't make sense to some extent. But your basic question can be something like this. Hey, SQL was invented to be a standard. Why are we using a different way of doing things in Web2Py? Why can't we just write SQL that everybody should know how to do it and this standard, instead of mucking around with this, with this Web2Py peculiar way of accessing the database, And so there are two reasons of that. The first reason is that Web2Py, if you look at the code here, when it creates the database connection, okay, fine, sorry, it gets it from this db.uri. But if you look at the, maybe in the database chapter, let me show you, because it's actually perhaps useful that you look at it. So this is the list of databases that are supported by Web2Py. Okay, you can use SQLite, you can use MySQL, you can use Postgres, you can use Oracle DB, you can use IBM's DB2, Ingress, Sybase, Informix, Teradata, MongoDB, Google SQL, Google NoSQL, all of these. And the only thing that you need to change going from one database to the other is essentially the way you connect to them. And Web2Py, via DAL, which is a data abstraction layer, will worry about translating your comments for the particular backend. So the first reason you want to use the database way, or the Web2Py way of accessing the database, is because you don't want to constrain yourself to a particular backend. Now, maybe today you think that you want to use MySQL, but maybe tomorrow somebody will convince you that Postgres is better, and so that you can change in a single blow. Okay. This is reason number one, compatibility. If not else, you develop on your laptop using SQLite, and then you deploy it in the cloud using actually a serious database, okay? So this is reason number one. Reason number two is this, who is a fan of XKCD? Everybody is, right? Is the answer. And so he wrote this very beautiful slide that let me show you in all its glory, essentially. Let me. So the problem is this, right? I mean, look at it a moment and then. So the problem is this. There are essentially few standard ways of shooting yourself in the foot in computer science. So one is buffer overflows, right? When you use languages such as C and C++, you allocate a buffer, you don't check that what you're putting in it is going to fit in the buffer. And so people are using it in order to craft attacks that, write too much content in the buffer to overwrite other portions of the memory space and get you do things that you ought not to be doing. Many attacks work in this way. And not only attacks to network protocols, but also attacks to media, right? if you are running an, I don't know, an MPEG H264 decoder that contains a bug, you know, in the way it's allocating internally buffers to decode video, I can craft a video that when you try to play it will, you know, exploit the weakness. So, you know, pervasive problem due to languages that, you know, allocate buffers statically and don't contain these checks, which, you know, they don't do it for efficiency, I guess, but you know, that, one way of shooting yourself in the foot. Another of the main ways of shooting yourself in the foot is quotations, or escaping, or sanitization. I mean, call it what you want. It's all, you know, it's all the same basic issue. The basic issue is this. I need to send some string to the database, and I need to essentially make it known which ones are the strings that I'm passing as part of the command, and which parts of the commands. So here, we see an example of these. I'm trying to say, hey, you know, I don't care about where to py, I can do better. And I'm trying to build a string that will generate the right insert into the database. And so I say, insert into students, email name, values. And then, you know, in SQL, I need to open the quote, then put the name of the student, close the quote, put a comma, right, and then go on. And so I say, you see, there is this open quote, right? Then I say plus the email of the student plus close quote, comma, open quote for the name. Then I put the name of the student, and then I close the quotes and put the semicolon that finishes the SQL command, right? Now, the problem of this is that I'm not sanitizing what is part of the email and what is part of the name. If somebody plays the hack that is depicted here, okay, maybe with a double quote instead of a single quote, you know, to adapt to what I wrote in my text, okay? Then what happens is that the student team, the name of, or the email of the student will contain inside it a quote that MySQL will interpret as the end of the email. Then a closed parenthesis, a semicolon that MySQL will interpret as the end of a command, and then another command that says drop table students, that will drop the table containing the students. So the only solution to this is to properly escape the characters that are part of the variables that you send to MySQL. So you would need to send something like this. Let me try to get a place where I can edit, right? But you will need to send essentially, insert into like students name. Let me do a table for this example, a table with only one, I can call it name, okay? Values, okay? And here, suppose that suppose that my name is really called Luca apostrophe close semicolon and then I don't know, drop table, okay? Drop dead, something like this. Suppose that this is really my name. Let me just shorten it, okay? So I cannot send it to the database this, obviously. Okay, so this needs to be properly escaped. How? Well, MySQL has its own specification of how to escape stuff, right? Which I actually don't know. I think it uses something like this, okay? But I don't know, and these escaping rules are difficult, and it's especially super easy to forget to apply them. Why? Because you write complicated code among multiple people, and then there is, you know, him and me, and there is, hey, you know, when you pass me the query, did you sanitize already? Oh, yeah, I did. Okay, yeah, fine. Because, you know, I cannot sanitize it twice, right? Because if I sanitize it twice, I do the substitution twice, and then MySQL will insert something that is not, you know, that will have an extra slash or whatever, no? So you have to sanitize exactly once. And it's hard in a big project to keep the discipline of where to sanitize. And so the best way to do it is to let it do to the Web2Py abstraction layer that will do it exactly at the point in which it's translating your Python to the underlying database command for whatever backend. That's where the sanitation happens. So the recommendation is never use raw SQL because it's too easy. And, you know, these are called SQL injection attacks. And, you know, even today, and this disappeared, goodness. But even today, these are some of the most common attacks. I believe that an attack against the target, you know, that fished out a gazillion credit card numbers, was an SQL injection attack. And you can just Google for SQL insertion attack and limit the results to, I don't know, to the last couple of years. You know, you have all the list of attacks. People really do these attacks, and then, you know, fish out. What you do is you don't drop tables. What you do is something smarter. You know, I created an account with your store. Well, maybe I shouldn't tell you how to hack things. But, you know, I create an account, and maybe in my account I have my profile, and then I do an injection attack that fishes out, you know, your credit card number and says, insert into Luca profile, select from John's credit card the number, no? And so what is selected from another credit card field gets put into my profile. Then I go to my profile and I say, haha, you know, that's a number, great. No, that's how you do it. I mean, yeah. But, you know, so these attacks are a serious concern. And so that's why you should always build sites using these indirectly. Okay, thank you.